So let's look at part 2 here. Now before we move on part 2, I just want to mention that this shouldn't be lambda because we already have lambda in the other equation here. So now just change it to any other alphabet here. So I'm going to use alpha instead. Now we are given the L contain plane tree, find lambda and mu. So I'm not sure what's going on, but I'm just going to draw it out first. So this is lambda, this is L. Alright. So this is L and lambda. So just draw it out. This is L here. I know that L over here, the direction is given by 1, 1, 1. We draw it at 1, 1, 1, and the point here is actually negative 1, negative 1, 0. Okay, then this is plane 3. Now, plane 3 contains L. So when we do this, what we're going to do is actually this is the normal here. And after which, what we're going to get here is just normal. Yeah, normally, the normal here, I'm going to write this in plane 3. R dot scalar product form 5 lambda, so it's just 5 lambda 17 equals to mu. Okay, so this is 5 lambda 17 for the normal. 5 lambda 17. Okay, now if the line is on the plane, so you can be sure if line is on plane, so the first thing you should know is actually the line is parallel to plane. It has to be parallel to plane, right? Now if line is parallel to plane, this would tell you that the direction of the line is actually perpendicular to the normal. Okay, so that's where the first clue lies. So this is where if we take d dot n should be equal to 0. So if you look at this diagram here, you get this is the normal here and this is direction. If you were to dot it, so I'm going to draw a parallel line here. So if this is normal here, if I'm going to dot this, it will be 90 degrees to it, right? So it will be parallel to it. So it just looks like that. Maybe I should just draw it like that. Okay, so like that. There you go. Okay, so d dot n, we're going to just take 5. This is 1, 1, 1, 1, 1, 1. Dot with 5 lambda 17 equals 0. So this would be 5 plus lambda plus 17 equals 0. So this is lambda equals to minus 22. Okay, so I got the first one. Now after which you should know that the point on the line will satisfy the plane equation. So the plane equation, let me just take this plane equation here. So I'm going to make a here what we're going to get is essentially plane 3. We're just going to sub a point in which is minus 1, 0. So sub point minus 1, 0 is on P3. Okay. Essentially what I get here is I could just substitute into the Cartesian equation. That would be good. So that will be sub x equals to minus 1, y equals to minus 1, z equals to 0 into P3. So this case here, okay, is 5 times minus 1 plus lambda, which is actually minus 22 minus 1 plus 0 times 17 equals to mu. So mu will just becomes 22 minus 5, which that would be 17. Okay, so that's how you do this part here proficiently.